Okay, so today we're doing minimum problem for FAANG minimum genetic mutation. Basically we can just change a single character we're supposed to get from some start string to end string, and there is some valid genes in between, and we return minimum number of mutations or -1 if you can. So basically that's like a BFS or something like that. Who cares? So let's do Q, DQ, start gene, bank, set bank, and then we go while Q, let's go it like gene is Q pop left, let's do it like, no, that's bank, we do like dist, start gene is equal to 0, right? For I in range, what's the length of the genes? Because length of bank is 8 only, okay. Because I mean, if you have 4 options, we don't want to iterate over all position and try all changes, because that's 4 to 8, so 2 to 16, which is not that much. But faster would be just iterate over bank, right? Check if there is at most one change. So for next gene in bank, right? And now if is like sum of gene I don't equal, do they have same length? Start gene in the bank, okay. Gene I don't equal next gene I, if don't equal 1, so this is 1 and this not in this, then this next gene is this gene plus 1, Q append, okay, and then we return what? Return this gene, this and gene in this else -1. So let's make a variable called len. It should work 100% easy. You can have at most what bank vertices plus, for each vertex we do length, so let's call it b plus l. So just a shortest path problem instead of trying all possible mutations, neighbors of each gene which is 4 to power or like 3 to power of L, where L is equal to start gene. We just try all genes in the bank, since there is at most 10 of them, and we just check if the difference is 1. O B plus L, where B is bank, since the longest path has a length of at most 10, at most B, and for each vertex we compare. Nah, it's actually bank squared. L times B squared. Compare for each gene vertex. We compare it with all other genes in the bank and iterate over all their positions. No, and iterate and count their okay. Okay, memory is, I guess memory for DFS is this, since we store we store distances for at most at most OB genes, and each has a length of L. Okay, post, and